What is the structural geology?
Structural geology is a critical part of engineering geology, which is interested in the physical and mechanical properties of the rock. Deformation histories help us also to remodel the nature of the forces which are related to the formation. Importance of the structural geology. The study of structural geology has a primary importance in economic geology, both petroleum geology and mining geology. The main target of structural geology is to use measurements to understand the stress field that resulted in the observed strain and geometries. We can also understand the structural evolution of a particular area due to plate tectonics such as mountain buildings and riftings. Objective. Structural geologists use a variety of methods to measure rock geometries, reconstruct their deformational histories, and calculate the stress field that resulted in that deformation. Geological timescale. The geological timescale (GTS) is a system of chronological dating that relates geological strata stratigraphy to time and is used by geologists, paleontologists, and other earth scientists to describe the timing and relationships of events that have occurred during Earth's history. The table of geological spans presented here agrees with the nomenclature, dates, and standard color codes set forth by the International Commissions on Stratigraphy. Our geochronological table, International Chronostratigraphic Chart. The largest defined unit of time is a superion, composed of aeons. Aeons are divided into eras, which are in turn divided into periods, epochs, and ages. The term eothem, system, erathem, series, and stage are used to refer to the layers of the rock that correspond to these periods of geologic time in Earth's history. A map legend is a table or chart included on a map to indicate the meaning of the map's varied symbols. This can be also called the map scheme. In structural geology, when we plot the cross-section, we use these widespread legends to show from what rocks our layer is consist of.
Earth layers. The Earth is composed of 4 different layers. The crust is made of the lightest material, and the core consists of heavy metals. The Earth layers are crust, mantle, outer core, and inner core that you can see in the following picture. The crust. The Earth's crust is like a thin of an apple. It's very thin in comparison of the other 3 layers. The crust is a layer that you live on, and is the most widely studied and understood. The crust of the Earth is broken into many pieces called plates. The plates float on the soft plastic mantle, which is located below the crust. Tectonic plates you can see in the following picture. The crust is composed of 2 basic rock types, granite and basalt, as I said before. The continental crust is composed mostly of granite. The oceanic crust consists of a volcanic lava rock called basalt. The mantle is a zone of the Earth below the crust and above the core. It is much hotter and has the ability to flow. The mantle is a layer located directly under the sima. It's the largest layer of the Earth, 800 miles thick. The mantle is composed of very hot dense rock. Outer core. The core of the Earth is like a ball of very hot metal. The outer core is composed of the melted metal, nickel and iron. Inner core. The inner core begins about 400 miles beneath the crust and is about 800 miles thick. The temperature may reach 90-100 degrees Fahrenheit and the pressure are 45 million pounds per square inch.
Anticline versus syncline. In structural geology, an anticline is a type of fault that is an arc-style shape and has its oldest beds at its core. A typical anticline is convex up, in which the hinge or crest is the location where the curvature is greatest, and the limbs are the sides of the fault that dip away from the hinge. And what is a syncline? In structural geology, a syncline is a fault with younger layers closer to the center of the structure. Anticline versus antiform and syncline versus synform. Additionally, when describing recumbent faults, following terms are used. The term antiformal anticline is used for describing an antiformal fault with the oldest rock in the core. The term synformal syncline is used when the synclinal fault has the youngest unit in the core. The term antiformal syncline is used for describing antiformal faults that have the youngest unit in the core, while synformal anticline is used to describe synformal faults with the oldest rock unit in the core. And what I have said about anticline versus antiform and syncline versus synform, we can see on the next picture. Domes and basins. Domes and basins are structures with approximately circular or slightly elongate, closed outcrop patterns. Domes are convex upwards. Basins are concave upwards. As these slides, we can see limbs and axial planes. And so, what is a hinge, limb, and axial plane? A fault surface seen in a profile can be derived into hinge and limb portions. The limbs are the flanks of the fault, and the hinge is where the flanks join together. The hinge point is a point of minimum radius or of curvature, maximum curvature for a fault. The crest of the fault is the highest point of the fault surface, and the throat is the lowest point. The inflection point of a fault is the point of a limb at which the concavity reverses. On regular faults, this is the midpoint of the limb. So, now we get to the fault. In geology, a fault is a planar fracture or discontinuity in a volume of rock across which there has been significant displacement as a result of rock mass movement. Large faults within the Earth's crust result from the action of plate tectonic forces, with the largest forming the boundaries between the plates, such as subduction zones or platform faults. Energy release associated with rapid movement on active fault is a cause of most earthquakes. Types of faults. A close look at faults helps geologists to understand how the tectonic plates have moved relative to one another. Types of movement of crustal blocks that can occur along faults during an earthquake. First, where the crust is being pulled apart, normal faulting occurs, in which the overlying hanging wall block moves down with respect to the lower footwall block. Second, where the crust is being compressed, reverse faulting occurs, in which the hanging wall block moves up and over the footwall block. Reverse slip on a gently inclined plane is referred to as thrust faulting. The third one, crustal blocks may also move sideways past each other, usually along nearly vertical faults. This strike-slip movement is described as sinistral when the far side moves to the left and dextral when the far side moves to the right. The fourth one, an oblique slip, involves various combinations of this basic movement, as in the 1855 Wairarapa fault rupture, which included both reverse and dextral movement. Horst and Graben. In geology, Horst and Graben refers to regions that lie between normal faults and are either higher or lower than the area beyond the faults. A horst represents a block pushed upward relative to the blocks on either side by the faulting, and a graben is a block generally long compared to its width that has been lowered relative to the blocks on either side due to the faulting. Horst and graben are formed when normal fault of opposite dip occur in pair with parallel strike lines. Horst and graben are always formed together. Graben are usually represented by low-lying areas such as rifts and river valleys, whereas horst represents the ridges between or on either side of these valleys.
Now we are going to the earthquakes. Earthquake is a sudden, rapid shaking of the earth caused by the release of energy stored in rocks. Why do earthquakes occur? Scientists believe that the movement of the earth plate bends and squeezes the rocks at the edge of the plates. Sometimes this bending and squeezing puts great pressure on the rock. Rocks are somewhat elastic, they can be bent without breaking. Continental drift is a movement of the Earth's continents relative to each other, thus appearing to drift across the ocean bed. The speculation that continents might have drifted was first put forward by Abraham Ortelius in 1596. The concept was independently and more fully developed by Alfred Wegener in 1912, but his theory was rejected by some for lack of mechanism. So this was supplied later by Arthur Holmes, and also because of prior technical commitments. The idea of continental drift has been subsumed by the theory of plate tectonics, which explains how the continents move. Plate tectonic boundaries. There are three kinds of plate tectonic boundaries: divergent, convergent, and transform plate boundaries. Divergent boundary. A divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, lava spew from long fissures and grosser plate tectonic boundaries. There are three kinds of plate tectonic boundaries: divergent, convergent, and transform plate boundaries. Divergent boundary. A divergent boundary occurs when two tectonic plates move away from each other. Along these boundaries, lava spew from long fissures and geysers spurt superheated water. Frequent earthquakes strike along the rift. Beneath the rift, magma, molten rock, rises from the mantle. It oozes up into a gap and hardens into solid rock, forming new crust on the torn edges of the plates. Magma from the mantle solidifies into basalt and dark dense rock that underlies the ocean floor. Thus, at divergent boundaries, oceanic crust made of basalt is created. You can illustrate the divergent boundary following picture. Convergent boundary. When two plates come together, it's known as convergent boundary. The impact of two colliding plates buckles the edge of one or both plates up into a rugged mountain range, and sometimes bends the other down into a steep seafloor trench. A chain of volcanoes often form parallel to the boundary, to the mountain range, and to the trench. Powerful earthquakes shake a wide area on both sides of the boundary. You can illustrate it in following picture. Transform plate boundary. Two plates sliding past each other forms a transform plate boundary. Natural or human-made structures that cross the transform boundary are offset, split into pieces, and carried in opposite directions. Rocks that lie the boundary are pulverized as the plates grind along, creating a linear fault valley or undersea canyon. As the plates alternately jump against each other, earthquakes rattle through a wide boundary zone. In contrast to convergent and divergent boundaries, no magma is formed. Thus, crust is cracked and broken at transform margins, but is not created or destroyed. Following picture illustrates transform, divergent, and convergent tectonic plate boundaries. Unconformity. Unconformity is a general term for missing page of Earth's history. There are three types of unconformities: angular unconformity, nonconformity, and disconformity. An angular unconformity, illustrated at the left, is an erosional surface separating steeply dipping rock layer below from the gently dipping layer above. Nonconformity, at the middle, is an erosional surface separating igneous or metamorphic rocks below from sedimentary strata above. Disconformity, at the right, is an erosional surface separating horizontal strata below from horizontal strata above and where there is a gap in time. Facies in geology is a distinctive group of characteristics that distinguish one group from another within a stratigraphic unit, or the general nature of appearance of sediments or sedimentary rock produced under a given set of conditions. Facies contrasting river channel facies and overbank floodplain facies in alluvial valley fields. Alluvium, unconsolidated clastic material subaerially deposited by running water, including gravel, sand, silt, clay, and various mixtures of this. Colluvium, unconsolidated, unsorted earth materials being transported or deposited on side slopes and/or at the base of slopes by mass movement and by local unconcentrated runoff. In this picture, you can see colluvium, alluvium, and fluvial facies.
And now we get to the remote sensing. Remote sensing is acquisition of information about an object or phenomenon without making physical contact with the object, and thus in contrast to on-site observation. Remote sensing is used in numerous fields, including geography and most earth science disciplines. For example, hydrogeology, ecology, oceanography, glaciology, geology. It also has military intelligence, commercial, economic planning, and humanitarian applications. In current usage, the term remote sensing generally refers to the use of satellite or aircraft-based sensor technologies to detect and classify objects on Earth, including on the surface and in the atmosphere and oceans, based on propagated signals. It may be split into active remote sensing, when a signal is emitted by a satellite or aircraft and its reflection by the object is detected by the sensor, and passive remote sensing, when the reflection or sunlight is detected by the sensor. So, what is the active remote sensing? Active remote sensing is a class of remote sensing that makes use of active remote sensors. These sensors provide their own source of illumination and they emit radiations that are directed towards the target body that is to be investigated. Active remote sensors emit energy in order to scan the objects and areas, and they then detect and measure the radiations that are reflected or are backscattered from the target body. Here we can see the diagram of active remote sensing. The next one is passive remote sensing. Passive remote sensing is a class of remote sensing that make use of passive remote sensors. The sensors are used to detect natural radiations that are emitted by the object or by its surrounding areas. The most common source of energy that is measured by passive remote sensor is reflected sunlight. Here we can see the graph how the passive remote sensing can be acquired and can be processed. So, thank you everyone. Geology rocks.